In this video, we're going to discuss significant figures. It's important to be precise in chemistry, and not every number is certain, and so therefore we want to make sure that we are only using those values that are. So therefore we're going to be using significant figures. There's a set of rules for significant figures to define what digits in a number are significant. The first rule, any digit that is not zero is significant. Rule 2, zeros located between non-zero digits are significant. Rule 3, zeros to the left of the first non-zero digit are not significant. Rule 4, zeros to the right of the last non-zero digit are significant if the number contains a decimal. Rule 5, zeros to the right of the last non-zero digit in a number that does not contain a decimal may or may not be significant. Rule 6, defined or counted objects are exact numbers. Exact numbers will have infinite significant figures. Now, to understand this, let's go back through each one of the rules and show some examples. So rule 1, if we have a number like 1,246, those are all non-zero numbers, so therefore we're going to have 4 significant figures, or sig figs. Rule 2, we're going to have, let's say, a number like 202. Here we have a zero between two non-zeros, so therefore that'd be 3 significant figures. And if we look at a number like 4.037, again, the zeros between non-zero digits, so therefore in this case we have 4 significant figures. From here it gets a little bit more complicated, but not too difficult. Just have to remember the rules. In Rule 3, we're looking at zeros to the left of the first non-zero digit. So if we look at 0.0081, think about what the zeros are doing. They're really just holding the place so that we know that this is not 0.81 and not 0.081, but 0.0081. In this case, we only have 2 significant figures. Another example, 0.00002. Here, all the zeros are just holding the place, so we'll know the quantity. So therefore, we only have 1 significant figure. Rule 4, zeros to the right of the last non-zero digit are significant if the number contains a decimal. If we look at 0.200, the number contains a decimal, so therefore the 2 zeros to the right are going to be significant, and this number will have 3 significant figures. Here the zeros are telling us something about the accuracy of the number. Another example, let's say we had $2,000. Because it contains a decimal place, we have not 1 significant figure, not 4 significant figures, but 6 significant figures. Rule 5, zeros to the right of the last non-zero digit in a number that does not contain a decimal may or may not be significant. So if we look at a number like 100, we don't know if that is exactly 100 or if it's 100 plus or minus 1 or 2, or if it's 100 plus or minus 10. So therefore, this could have 1, 2, or 3 significant figures. We really don't know. And in fact, it could have more than that. The best way to give the correct number of significant figures when we look at a number like this is to use scientific notation. So 1.0 times 10 to the second, that would tell us that we have 100. It not only tell us that that's 100, but it would tell us that we have 2 significant figures. So scientific notation is an excellent way to give the correct significant figures. In Rule 6, here we're talking about, let's say we had 6 beakers. Well, you can't have a partial beaker, and you're going to figure out how many beakers you have because you're going to count it. So therefore, 6 is an exact number. Also, if we take something like 1 foot is equal to 12 inches, well, this is actually a definition. So when we think about conversion factors like this definition, we put 1 foot over 12 inches. The truth is that has infinite number of significant figures because it's an exact definition. Same thing would hold true for something like 1,000 meters is equal to 1 kilometer. It's going to be an exact number. If we look at addition and subtraction, let's say we take 24.7 plus 1.14, add those together, and we're going to get 25.84. Now, if we look at our two numbers, one goes to the 100th position, the other one only goes to the 10th position. We have to go with the least number past the decimal point. So therefore, we're going to have to round this number to 25.8. In multiplication and division, what we have to do is use the lowest number of significant figures. So if we take 1.2 times 6.025, we would get 7.23. But since the first number only has 2 significant figures and the second one has 4 significant figures, we're going to have to round our number to just 2 significant figures, 7.2. The other thing to consider is conversion factors. So let's say that we're doing a unit analysis and we're going to do unit conversion from grams to milligrams. So we start with 2.25 grams. Now we know that we're going to need to convert that, so we use the definition of 1 gram is equal to 1,000 milligrams. We get the answer 2,250 milligrams. Now how many significant figures should we have? Well, if we look at this, we have 3 significant figures. Because we're taking something with 3 significant figures and we're multiplying it by an exact number. Therefore, we should have 3 significant figures. Now, is this the best way to represent 2,250, the best way to represent 3 significant figures? No. It has a 0 to the right and it does not have a decimal. So therefore, the best way to give the answer here would be 2.25 times 10 to the third milligrams. This represents the fact that we only have 3 significant figures.